Hello? I know. No, with no enthusiasm anymore. Okay, we all gave up. All right, optimization. This is actually, I think of it as the most calculus type of problems. If we were to say anything would sum up calculus 1, it would be these problems here. Optimization is the big deal about calculus 1. Every single time you're going to find one of these are going to be the free response for your, at least one, free response for your AP exam. Okay, if you were to take calculus in college, this would be the major big theme overall, blah, blah, blah. All the stuff, okay? This sums up just basically everything. Now, optimization means it's either going to be minimum or maximum of some type of word problem. So you're optimizing. So if we're maximizing an area, that means whatever function we have, the function would be at the maximum, and we're trying to maximize the area of some given boundaries. Or if we're minimizing cost. This is actually one that's used in business a lot. So if you're taking the business calculus, minimizing with multiple variables is important for this. Okay, so steps for solving optimization problems. This is going to be true all the time, and I'm going to ask you this anytime you ask me one of these questions. Read the problem until you understand it. So now, I want you to read it once. Okay, read it all the way through once. Then as soon as you're done reading it once, read it a second time, but now the second time you need to identify the important information. Okay? Okay? You can identify quantity which that it is maximum or minimum. Values can be found. Sign symbols to represent it. So, you're going to look to see if it's minimum, maximum. You're going to look for shapes. You're going to look for values. You're going to look for little things. Okay? Some of these things that it doesn't give you much information, but it might just say like a one word. Okay? One word. So if it says a radius is this. A radius, what does that imply? Something with a circle, right? So it's either going to be a cone, a cylinder, or just a circle. So those type of things that you have to pick out from here. Assign symbols to represent other variables in the problem. If possible, draw a picture, label it, determine relationships among the variables. Drawing it is probably one of the biggest things that is going to help you on this. Draw it out, label it, you can see what is it doing. Express the quantity and maximize or minimize as a function of one of the variables. Determine the meaningful domain for the function. Find the absolute minimum value or absolute maximum, absolute minimum value of the function. Okay, if we're talking about people on a plane. So if we're maximizing people on a plane, what would the actual domain be? If we're maximizing people on a plane, what would the domain of that be?
How many people can be on the plane?
How many?
People can be
Yeah.
on the plane?
Okay, so think of the numbers. What would the numbers be of that? What type of numbers?
Real numbers?
Real numbers. Okay. You're not going to have an imaginary person, right? Okay. Anything else?
Positive.
Positive numbers, right? I'm going to have positive. Can't have any negative people unless they're sitting in this class right now. Come on, that was funny. I was building up to that joke. Wow. Okay. Okay, so now, hello? Okay. Now, we're going to have positive real numbers, but now, are we going to infinity? No, we can't go to infinity, right? We are going to have a bound, so of a certain amount of people, so a maximum amount of people in there, given some constraints. Okay, stuff like that. So it's important. So for dealing with time, no timing here. Kind of maximize the time. I think we might have one of those. Anyway, but still. Farmer. Okay, what did I say? Read it. Let's go through this. A farmer with 400 meters of fencing wants to enclose a rectangular plot that borders a straight river. The farmer does not fence the side along the river. What's the largest rectangular area that can be enclosed? Okay. There is step one. Step two. Read it again, but now this time do what? Important things. 400 meters of fencing. Ooh. 4,000, sorry. Okay, so 4,000 meters of fencing. What was my key word right there?
Meter?
Nope.
4,000.
Nope.
Fencing?
Fencing, thank you. Yeah, there's only like 2-3 words there, so it's not of, okay? Yeah, of is not a good one, but fencing is the one we're looking for. Now, the word fencing implies that it's what? Perimeter, thank you. That's what we need to get out of that information. So fencing means that I'm going to have perimeter there. That's great. That's the important information from that right there. Okay, wants to enclose a rectangular plot that borders, ooh, rectangular. That gives me a good shape, right? Okay, that's good. That borders a straight river. The farmer does not fence the side along the river. What's the largest rectangular area that can be enclosed? Ooh. So that means it's going to be area, right? Okay. So, rectangular area. I already have a picture on your notes for this so you guys can see, a good diagram what this is going to be. So, I don't like the way that they use X, X, and Y. Use whatever you want. Okay? I like up and down always being Y. I like left and right always being X.
So this like this.
Huh?
This.
No, it's not.
Up is Y.
Up and down.
Well, it's the opposite.
It's ABC. Yeah, it's actually
Really?
ABC.
What?
We call the size rectangular ABC.
Okay. Whatever. Anyway. Alright, so. Alright, okay, so good. So now, a couple things that we have. So we have, let's talk about perimeter. P is 4,000 meters.
Oh, I said it was 4 infinity 0 meters. It was just like.
Alright? So, what's the formula for perimeter now? I know the value of the perimeter, but what is perimeter? What is the formula? P is equal to, now in this case, we use X and Y, right? So what would the perimeter of this be? What, using those variables right there, what would, so it would be 2x plus y. Do you agree?
Yeah.
Okay. Did you get the notes?
Yes.
Okay. P is equal to 2x plus y. So that's very good. That's good information that I have there. Yes? Okay, good. All right, so now let's take a look. Let's go to the next part. The next part right here. So, right here, rectangular area. So, the area, how would I find the area? Area is equal to x times y. Yes? No? Maybe. Okay, good. So now, for this problem right here, I need to know that I am going to maximize something. What am I maximizing? Area. Maximizing the area. So what function do I have to maximize? Am I maximizing the perimeter?
No.
Say no. I'm not maximizing the perimeter, I'm maximizing the area. Yes? Good, that's important. So now what I'm going to do is I have some values over here that I was given from the perimeter that I'm going to use for this. So I know that the P is 4,000, right? So this is going to be 4,000 equals 2x plus y. When I do this, I'm going to take the derivative, okay? Because to maximize it, I want the derivative, right? I want the derivative, and to get a maximum, the derivative has to be equal to 0. Very good. The derivative to get the maximum is equal to 0. So that's a minimum or maximum, right? That's where I get my critical points. When my slope is equal to 0. So that's my min or max there. Now, looking at both of these right now, I only want one of my variables. So what can I use? What can I do with this?
Take out y. Like we say that y equals.
Y equals. So I'm going to substitute this information, right?
Yeah.
I'm going to substitute this summation. So I'm going to say that y is going to equal 4,000 minus 2x.
Then plug it in.
Yep. Now I'm going to plug it into my area. Okay. I don't want to take the derivative of this with both these things right here, because I would actually end up having two different equations. When I end up with this, I would have a d. When I do implicit here, my implicit differentiation, I would have a dx, right? And I would have a dt, or dy, I'm sorry. So now we're maximizing the area. So area is equal to, it's going to be x quantity, because I'm replacing the y, 4,000 minus 2x. So let's go ahead. I'm going to distribute. Okay, hold on. I'm going to move this to the next page because I'm going to run out of room here. So A is equal to X quantity 4,000. Okay, so I'm distributing. So A is equal to 4,000 X minus 2X squared. So I'm going to end up with my dA, and I'm taking the derivative in terms of what? What? X, right? It's in terms of x. So this is going to be dx, right? Taking the derivative, so of a in terms of x would be taking the derivative of this is just going to give me 4,000 minus 4x, right? Yes? Okay, good. All right. And we said we're maximizing this, right? So this one has to be equal to 0. So I took the derivative, and this thing right here has to be equal to 0 to maximize it, right? So let's set that equal 0. So 0 equals 4,000 minus 4x. So negative 4,000 equals negative 4x divided by negative 4. X is 1,000. My units are meters, right? So I got X is 4,000, right? Or 1,000, I'm sorry.
And then
So I'm gonna go into this spot right here. So P, so for this right here, 2x plus y, right?
We have that y equals 4,000 minus 2x. We can find that.
So 4,000 equals 2, and my x is gonna be 1,000 plus y. So this is gonna be 2,000. So y is 2,000. So I got the y value, I got the x value. So now let's give it into wording and let's talk about what it is. So my x right here, so for my rectangle, this is going to be 1,000 meters. This is 2,000 meters. And the maximum area. That's the word I'm looking for, right? I'm maximizing the area. I got the dimensions to maximize the area. So the maximum area I would get out of this would be length times width, or the x times the y. So it's going to be with 6 zeros. And that's going to be meters squared. Was that 2 million? Yeah.
That's a lot.
Yes, it is. You're maximizing a lot of area. How you guys feel about this?
It's cool.
These ones aren't bad. They're really not. Okay, questions, concerns, complaints?
So calculus is useful for what?
Okay. So the question goes back to, what was the largest rectangle area that can be enclosed? So given my x was 1,000, my y is 2,000, the maximum area is 2 million meters square. That's it. Okay, we'll save this one for tomorrow. Okay, don't forget, you only have 3 problems for homework.